A study was conducted to see if a new drug has a significant effect on blood pressure. Patients known to have high blood pressure were separated into two groups. One group was given the new drug, and the other group was given a placebo. Both groups were put on a strict diet that is designed to reduce blood pressure. Of the 757 patients given the new drug, 520 showed a significant reduction in blood pressure. Of the 757 patients given the placebo, 375 showed a significant reduction in blood pressure. Test at a 0.05 level of significance to see if a treatment that consists of the new drug combined with a special diet is more effective at reducing blood pressure than the diet alone. So in order to do this test, a test about proportions, we're going to need to separate the two groups into group 1 and group 2. And it doesn't matter how we do that, we just need to be consistent from the beginning of the problem to the end, and then also in the comment in our analysis. So if we call group 1 the treatment group, then we can go through the problem here and find N1 and X1, which we're going to need when we do a proportion problem. And in the problem it says, of the 757 patients given the new drug, so the number of observations here was 757. It says that 520 showed a significant reduction in blood pressure. So if then a success is finding someone who showed a significant reduction, then the number of favorable observations would be 520. Of the 757 patients given the placebo, so that tells us then if group 2 is the control group, or the group given the placebo, then N2 is also 757. It says that 375 showed a significant reduction in blood pressure. So that means then that X2, the number of favorable observations, is 375. Now, if we were to draw a picture of this situation, we would use a normal distribution, and in order to do that, we would have to ensure that all conditions for using the normal distribution have been met. So in our normal distribution here, in the middle, we would have our difference in proportions. And we'll have this 0 in the middle. Then to the right would be a positive difference if P1 is greater. And then to the left would be a negative difference if P1 is smaller than P2. Now, what is our problem asking us to do here? It's asking us to test to see if a treatment that consists of the new drug combined with a special diet, so that means then the proportion for the treatment group, is more effective at reducing blood pressure than the diet alone. So in other words, is the population proportion for group 1 larger than the population proportion for group 2, which would make this a right-tailed test. We're supposed to test at a 0.05 level of significance. Alpha is 0.05. So since this is a one-tailed test to the right, our entire level of significance here would be concentrated all up here in the upper tail. So our hypotheses then would be, in the null hypothesis, no difference. P1 minus P2 is 0. That there is no difference between these two proportions. Our alternative hypothesis then, what we would conclude if we land in the rejection region, is that this difference is greater than 0. Now this could also be presented as P1 equal to P2. That's the same as P1 minus P2 equal to 0. And paired with that, P1 greater than P2. That is the same as P1 minus P2 greater than 0 if we added P2 to both sides. So it could be presented in either way, this pair or this pair. So what we need now is a critical z-value. And when you take the AP Statistics exam, as in this example from 2012, you will be given a series of tables that will aid you in finding these critical values. Now we're looking for a z-value where we would have 0.05 up in this tail. And if we have 0.05 up in this tail, that means we have 0.95 in this shaded region here. So if we look through the body of this table for where we have 0.95, we would find that it isn't here, but we do have these two values here, 0.9495 and 0.9505, which occur at 1.64 and 1.65. Now this is not a linear relationship, but this is one case where the value is interpolated to be 1.645. Halfway in between these two values would be 0.95. And halfway in between 1.64 and 1.65 would be 1.645. So our critical value would be 1.645. We could also find this value using the inverse normal function on the TI-83 or 84 calculator. We do that by pressing second, variables, and then 3, inverse normal. And here we have the area, then the accumulated area up to that z-value, so we have 0.95. And then since this is a standardized normal distribution, we'll have the mean at 0 and the standard deviation of 1. Come down and hit paste. And we have this syntax here that you would type in if you are using an TI-83 or 84 calculator that does not have that menu selection there. So we have first the area, then the mean, then the standard deviation. And if we hit enter, then we'll see this 1.645 if we round to 3 decimal places. We can also use the TI-84 calculator to find our test statistic. If we click Stat and then go to Tests, what we'll want to use is number 6 for 2 proportion z-test. Our group 1 had a number of successes of 520 and a number of observations of 757. And then group 2, 375 and 757. We want to make sure that we get the direction of the alternative hypothesis correct on this line. And remember that we said that this could be stated as P1 greater than P2. So since it's a right-tailed test, we'll choose greater than. And we'll come down and hit calculate. And we get a z-test value of 7.580 if we round to 3 decimal places. Let's also note that our p-value is given to us in scientific notation with an exponent of -14. So that means we have to go out to the 14th decimal place before we find a non-zero value. So this value is very, very small, certainly smaller than 0.05. So whether we use our p-value and compare it to alpha or our z-test value and compare it to our z-critical value, either way, the conclusion should be the same. We should reject the null hypothesis. And we should articulate our conclusion by saying something like, sufficient evidence was gathered at the 0.05 level of significance to conclude that a treatment of the new drug combined with the special diet is more effective at reducing blood pressure than the diet alone.